Hi everyone, in this video we're going to be deriving our kinematic equations for constant acceleration. Coming right up. Today we're going to be solving for our 4 kinematic equations for constant acceleration. So let's start with the definition of acceleration, which is only acceleration equals to the change in velocity over the change in time. For all of these questions, we're going to assume that our t initials or initial time is equal to 0, because we're just going to start in 0. That's going to make all of our equations much easier. Here all we have to do is, well, the change in velocity is just my v final minus my v initial over and just my t, because my t0 equals to 0. Now we want to solve for v final for our first kinematic equation. So all we do is we get our t on this side, so we have a t, v final minus v initial. So we have final velocity equals to v initial, because once we move it to the other side it's a plus acceleration times time. And that's the first kinematic equation that we usually see for constant acceleration. So to get our second one, we can see that our velocity time graph actually is only a linear change. Well, because my acceleration is constant, my velocity against time moves linearly. That means that if I'm going to take my average velocity, that's always going to be equal to my final velocity plus my initial velocity over 2. And our definition for our average velocity is equal to my change in displacement over my change in time. Remember? So now we have these two are actually the same term. Let's equal these two to solve for my final displacement, which is going to be my second kinematic equation. Now we will try to solve for my final displacement here. So let's just do that. I have my, well, f final minus x initial, and I'm just going to multiply the t on the other side. That might be final plus v initial over 2 times t. So we can just bring this over and we solve for my x final, so my final position, and that's going to be plus, and then we have 1/2 times my v final plus v initial times t. That's going to be my second kinematic equation. See how this term is my final velocity? We can plug this into here. So the next equation will not contain final velocity. It will only have initial velocity, time, acceleration, and initial displacement. That way you can also solve for your final final position without knowing the final velocity. So let's do that. So I have my x final equals to my initial position plus, then you have 1/2 times, and then we have to include this initial plus at plus v initial times t. Now let's solve for all these terms, so we have the variables together. So I have my x final equals to my x initial, and then I have plus, well, I have 1/2 b initial, 1/2 plus 1/2 b initial here, so I have these two terms, so it's just 1 v initial, right? Then I have plus 1/2 at, and all of these times this t. My x final equals to my x initial, and then we'll just multiply by t, so we get my velocity initial times t plus my 1/2 acceleration t squared. And that's my third kinematic equation that you usually see to solve for constant acceleration. So now we can go back to this equation and substitute by our t. So we want to get rid of our t in that equation so we can solve for our final velocity. The easier equation we have for time is the first one we work with. So I'm going to write it back here. So it's our acceleration definition, which is equal to my change in v over my change in time, or equal to my v final minus v initial over time. So I want to solve for time, so I can substitute it there, equals to my v final minus v initial over acceleration. So let's plug these back, in here. So now let's just compute this together so we have a final answer. X final equals to, then we can multiply this. We know it's going to be, well, b final velocity plus initial velocity times final velocity minus initial velocity is just final velocity square minus initial velocity square, right? Then you just multiply, well, the 2a at the bottom, then plus my initial position, let's not forget that term over here. And now we want to solve for our final velocity. We can leave the square there. First do, well, my final displacement minus my initial displacement times 2a equals to my final velocity square minus my initial velocity square. Let's move the final velocity square on this side. We have my initial velocity square plus, and then it's 2a, and this is only my change in displacement, so I can just write it as my change in, well, displacement. In this case I'm writing as x, which is x final minus x initial. So this is actually my last kinematic equation here. So there you have them. Those are the kinematic equations we've been using for constant acceleration problems. Most likely you will not need to derive them like that, but as long as you feel comfortable using them, you know when to apply them, how to apply them, then you should be good to go. However, if you do have any questions or any comments on how we derive these formulas, please let me know.